Hi, I'm Bryant, tutoring high school chemistry. Today's topic is kinetics. Kinetics is the study of motion of reactants and products in a chemical reaction. So the basis of kinetics you need to worry about is collision theory. Collision theory explains how reactants, react. Take, for example, the chemical reaction H2 plus I2 yielding 2HI. Let's visualize this in a system. We've got a bunch of H2 molecules floating around like this, and a bunch of I2 molecules floating around like this. And sooner or later, they're going to bump into each other, and a bond is going to form. But maybe not like this, because if you just hit this end H with that end I, you have an H floating around and an I floating around, and that just makes no sense. Collision theory explains that although your reactants do have to bump into each other, they have to hit each other in the right way. For this particular reaction, the H will have to bump into the I, and the other H will have to bump into the other I. So a bond can be formed between these two as these ones are broken, leaving you with 2HI. The other thing to remember is you need sufficient energy. If you don't meet the energy demand, this won't happen. So you can use this and apply it to reaction rates. If the concentration of your reactants increases, then they'll be more likely to bump into each other. And if they bump into each other more, then they're more likely to bump into each other in the right way. As concentration increases, your reaction rate will increase. The next thing is surface area. So the best example is dissolving sugar into a cup of tea, or coffee, or whatever. If you dissolve it in a bunch of granules, water will be able to hit it from all sides, so it dissolves faster. But if, instead, you drop in a sugar cube, same amount of sugar, water, the tea or coffee, can only hit on the surfaces, but not any of the sugar inside, which it could hit if it were in granules. So the sugar cube dissolves not quite as quickly. Same thing with reactants. More surface area, faster reaction. The next thing is temperature. If you increase temperature, molecules tend to move around more quickly, which means they'll hit each other more, which means they're more likely to collide in the right way. So that results in an increase in reaction rate. Bond strength. If the bonds between your molecules are stronger, then you need to put in more energy to break them. As a result, the stronger the bond, the slower the reaction rate. The last thing is a catalyst. Catalysts I'm actually going to talk about for a little while. What they are. They're usually some sort of molecule or compound that, although is unchanged by a reaction, same in the beginning and end, it helps the reaction proceed along. You see, this chart is something of a reaction. Things start here with the reactants, and this is the energy in them. Notice the increase in energy. This is the energy you have to put in. It's called activation energy. All reactions need some energy to start off. What a catalyst does is lower the amount of activation energy. That means you need to put in less energy to get the reaction started, meaning that less energy to break those bonds. So if you put in a catalyst, your reaction rate will increase. And it's as simple as that. When you're asked questions, it'll tend to be just on this table and collision theory. Just know how it works. To recap, collision theory explains how reactants react. They need to hit each other in the right way, and they also need to have enough energy. Reaction rate is increased by the concentration of reactants, surface area, temperature, and catalysts. If your bond strength increases, though, the reaction rate will actually decrease. Okay, that's all for now. Again, I'm Bryant. See you next time.